Hi everyone, here I am going to talk about carbon and its compound, and here I'll talk about carbon and oxygen. So I have written four compounds here and all contain oxygen, but let us differentiate between each of them. So whenever there is OH, it is called alcohol. Okay, then CO, whenever there is CO, that means RCOCH3. Okay, CH3COCH3, then this is called ketone, and this is called ether, and this is aldehyde. So all these are functional groups. So to make it more clear, I will draw the structure as well. So drawing the structure will make you more clear. So as a student, you should practice the structure as well as the formulas, so it will make you more clear about organic chemistry. So let me draw the structure of this alcohol. Okay, this alcohol. So alcohol CH3OH, that means CH3, oxygen is single bonded on both sides. Here this is R group. Okay, this is called your R group, that is alkyl group. Okay, alkyl group, and this is O, then this is H. So this is, whenever it is in this form OH, ROH, then this is called alcohol. Okay, so the bonding of oxygen is here single bonded, one side hydrogen, one side carbon compounds. Okay, carbons, that means carbon chain. Okay, it can be any chain, it can be longer chain, it can be branch chain, it can be any chain, but whenever there is carbon, oxygen, hydrogen, this is called alcohol. Now let me draw the ketone here. Now what is the formula of ketone here? The formula of ketone. Okay, the formula means the given compound here, CH3COCH3. Okay, so you can write, sometimes you will find in this way. So that means we should know that there is connection of bonds. Okay, you can write in this way, or you can write in this way to be more clear. Once the structure are clear, the formulas become more clear. Okay, so here see CH3, this what is the bonding of oxygen? Let's see the bonding. Carbon, this single carbon with double bonded oxygen here. Oxygen is double bonded here. Okay, so whenever we see C double bonded O, okay, then we have to know that this is carbonyl, that means this is carbonyl group. And on the left side, on the right side, if there is carbon chain, okay, then this is called carbon chain, means alkyl group, this is called ketone. Okay, so ketone is always, the connection of ketone oxygen always C double bonded O. So this side, left side, either both side, that means both sides should be R. Okay, R means carbon chain. It can be branch or it can be shorter chain, it can be longer chain, any chain, but this side should be carbon chain. Now let us go to another one, ether. So when I say ether, we write as CH3OCH3. So this is ether. I have taken particular ether here. So this is ether. So how to identify ether? See, all contain oxygen, but alcohol is connected with the OH. Okay, then we will know that this is alcohol. ROH. ROH. Okay, so then again ketone, there is oxygen, but this is C double bonded oxygen. Let's see whether this, what type of bonding. So CH3O CH3. Okay, so it is almost similar to that of the alcohol. See, in the alcohol, one side of the oxygen is H, but in this case both sides should be R. Okay, that means carbon. So this is also similar to that of the alcohol, single bonded on both sides, ketone, double bonded oxygen. Okay, so next we will go to another one, that is aldehyde. Okay, aldehyde. Let's go to aldehyde. The aldehyde formula is here, given here. We have taken CHO. Okay, so for aldehyde, whenever you see CHO, whenever you see this CHO, this is called aldehyde. Okay, whenever alcohol, whenever we see OH, this is called alcohol. But for ketone, when we see that means single CO, then we understand that this formula, this compound is ketone, CO. Okay, an aldehyde, we will, whenever we see CHO, this is called aldehyde. So let's see the bonding, the structure to make us more clear. CH3 bond C, double bonded O, okay, double bonded O, then H. So it is almost similar to that of the ketone. See, here aldehyde and ketone are always connected with C double bonded O, C double bonded O, okay, and this side one is carbon chain and this side is hydrogen. But in case of ketone it was CH3, but in this case it is H. Okay, so aldehyde always remain at the terminal, always will remain at the terminal. Okay, so this is the difference. So let us check the formula now, how to differentiate between alcohol, ketone, ether, aldehyde. Okay, so in case of alcohol, it is always whenever we see OH, this is called alcohol. When we see CO and this side is CH3 or any carbon CO, but CH3 carbon chain, that is called ketone. When there is no C, there is no C here, see only single O, and this side are CH3, okay, but there is no single C here, so this is ether, like OH, here it is CH3, okay. CH3CHO, whenever we see CHO, it is called aldehyde. As well as we should know the clear structure, the clear bonding of all these compounds, okay. And to make it more easy, how to remember all these compounds easily, first you remember about water. Okay, water has this type of bonding, right? Okay, this type of bonding, HOH. Okay, so same thing, just remove one of the hydrogen, just remove one of the hydrogen by CH3, okay, CH3, then OH, it becomes, it changes from water to alcohol, okay, it changes from water to alcohol. Now this and this are almost similar, just by removal of one hydrogen by R group, okay, it becomes alcohol. Now for ether, this, and for again for ether, I have not talked, okay, for ether is again just replaced the two hydrogen of the water by R, that means carbon, okay, carbon chain, that then it becomes as ether. So once you know water, you will be able to easily remember about alcohol and then about ether, okay. So these three are very much similar. So just remember water first, then see, remove one of the hydrogen by CH3, it becomes alcohol. Just remove both sides of the hydrogen by carbon chain, then it becomes ether. Now in case of aldehyde and ketone, whenever you see for aldehyde CHO, then we will say that any chain, okay, here I have taken acetaldehyde. So in CHO, whenever you see, that is aldehyde. Whenever you see in the form of R, that means carbon, then in the form of CO, okay, single C with oxygen, that means single C with oxygen should be always double bonded oxygen, then R, this is called what, this is called ketone, okay. So in this way you differentiate yourself the differences by drawing the structure. Once the students are clear with the structure, the formula also will become clear, okay. The formula comes easily, that you can differentiate it easily. So whenever you practice organic compounds, always try to draw the structure, their bonding, and as well as the formula itself, okay. That will makes you easy in learning chemistry, organic chemistry. Thank you.